All right, let's start the second part of this problem from section 4.3 and 4. I'm peeking back here, derivatives and shapes of curves. We looked at the first derivative, let's look at the second derivative. What does the second derivative give us? Second derivative gives us information about concave up, concave down, and inflection points. Okay, so the above here, first derivative is all about increasing, decreasing, and local maximum, called extremum. All right, down here, second derivative. So looking at our first derivative, which is, where's our first derivative? Right here. I need to do quotient rule again. You ready for this? Low D high minus high D low. Okay, here we go. Low D high, so look at this. Low, take the derivative of the top, it's 8, minus the top times the derivative of the bottom. Now the bottom is chain rules. I'll bring the 2 in front, and this is x squared plus 1, plus 4 to the 1 power. So that comes down in front. Derivative of the outside times the derivative of the inside is 2x. All right, all over the denominator squared. So if I square square, I get 4th power here. Now this is a little bit messy, you all. Sometimes that second derivative, especially in quotient rule, can lead to more difficulties. So what I'm going to do is think of this as 2 terms in the numerator and simplify. So if I simplify that, I'll probably put the 8 in front. Now look at this one, 8x times 2 times that times 2x. So I'm going to take 8x times 2 times 2x and get, how about that? All I did was put the 8 in front of that. And now I took the 8 times the 2 times the 2, which is 32, and then the x times the x, which is x squared. Now you could multiply this all out, but it gets really, really messy. So let's convince yourself that that's true. Those 2 terms look like this. Now I'm looking at these 2 terms, and I'm going to factor out a greatest common factor, factoring. I look at the 2 terms, and I see I have an 8 here and a 32. 8 does divide 32 4 times, so I'm going to pull out an 8, but look at this x squared plus 4 squared, and x squared plus 4 went to the 1 power. I can factor out the lower power, so look what I've done. I've factored out an 8 out of both terms. I've factored out one of these x squared plus 4s. And now I've got a parenthesis, so if I pull an 8 off, and one of these, I'm left with x squared plus 4. Then minus, I took 8 off there, so I have a 4 here. And I took this entire x squared plus 4 out in front. And now I have a 4x squared. All right, so think about that. Sometimes it's easier to think about it if you distribute. See, distributing is the opposite of factoring out. So if I took 8x squared plus 4 times that, that'll give me this. Minus, if I take 8 times 4, it's 32, and then I've got the x squared, and then I've got 1 factor of x squared plus 4. Factoring out of 2 very large terms. I took an 8 off both, and I looked at that as, you're not used to factoring things like this out, but I'm going to factor out x squared plus 4 to the power of 1. And that leaves me with x squared plus 4, and then minus that one got factored out. And I get 4x squared now. The nice thing there is that this simplifies here into x squared plus 4 minus 4x squared is just 4 minus 3x squared. See, x squared plus 4 minus 3 of those, I've got just the 4. I absorbed those 2 together and got negative 3x squared. And now everything's factored on top. That's pretty useful. And also look, this and this, if that would reduce to a 3. And now I have 8 times parenthesis 4 minus 3x squared over x squared plus 4 to the cube. Now I set it equal to 0, and as I said before, you set the top equal to 0 and the bottom equal to 0. So if I set the top equal to 0 and the bottom equal to 0, right here you're going to get a non-real, which is something we got up here when we set that equal to 0, because that x squared plus 4 here, if I set that to 0, is not real. You can try it again. And this one I'll just set the 4 minus 3x squared equal to 0, bring 3x squared, divide by 3, I get square root. It's about plus or minus 1.5, or 1.15. All right, now we're talking about the second derivative. And the second derivative, I'm going to plug in a value here. I plugged in, what did I plug in? F of, it wasn't easy. I plugged in f of -2 into the second derivative. So it's big and hairy and awful. And I got negative. I'll let you plug it in. You plug in 0, not as bad, but you get positive. You plug in 2 into the second derivative. Remember, so label that second derivative so you know what to plug it into. And this right here is negative. Okay, so don't forget to check those values. Make sure you get positive, negative, or negative, positive, negative. And what that means is concave down, concave up, concave down. So f is concave down on negative infinity to negative 1.15, union 1.15 to infinity. F is concave up on negative 1.15 to 1.15. And f has inflection points because there's a change of sign here and a change of sign here. We've got an inflection point here and here. Now remember that we plug that back into the original function way back there. Okay. And that will give us inflection points at negative 1.15, 2.48, 1.15, and 2.48. These 2 points are your inflection points.